The last part of the stage of the first tutorial begins with filling the foundation with an aggregate. You will witness of the proper way to compaction of that aggregate and its preparation for the implementation of the concrete floor. While performing this work, a sewer system ought to be performed in parallel, concern of course the part of which is located under the floor of the building. Pipeline execution plan, type and the size of the pipes that we should use for this job, we can read from sewer project, that is additional part of the building project. In that project, we also find the slope of the pipeline and all the necessary information regarding its proper implementation. The pipes go outside of the building at the location specified in the project of the sewer connections. First, we will assemble a widest tube of 20 cm diameter, which is directly connected to the municipal sewage system. Then, by using the branchy pipe fittings, we will branch pipeline and run separate parts of it towards the appropriate riser pipe drains. To change direction of the pipes, we will use joints commonly named elbows that are produced in several variants of the angle. Be sure not to use the elbows in angle of 90 degrees, because this one causes in certain situations the risk of clogging the pipes. Sometimes it will be necessary to break through the wall of the foundation. In this case, you will have the opportunity to know how strong such construction is. Looking at the foundation I have done here, you probably request an answer of the question, why is it placed so high on the ground? In the first part of the presentation, I mentioned that the depth of the foundation of the building is defined in the zoning for the site, so as an investor or contractor, we don't have to impact of this state of affairs. Sometimes, as in this case, the investor is exposed to considerable additional costs. The foundation will not only be filled inside, but also must be overhanged and thickened with its outer parts. But nothing happened without a reason, however. On the first of the movie, you was witness of the local soil conditions, so despite of considerable cost associated with incurring land, in this case it was absolute necessity. This particular foundation has a volume of more than 100 cubes, so to fill that it was needed 24 huge trucks full of aggregates, so this is a really huge quantity. For filling basement, as usually, I use a backhoe loader, which, as I mentioned at the outset, is a very flexible tool. As can be seen in the film, thanks to boom of the excavators, which reaches to more than half of the building, operator has the ability to evenly distribute the aggregate, which is quite crucial during compaction of the material. You can see the installation of sewers once more. Now it is light on compacted soil. Performing thickening proceed in this place, be careful to don't damage the pipeline. It is good to find the plumbers as well as electricians before you finish this part, because it is the moment where we still are managed easily lie below the foundation bench, water pipes and conduits through which an electrician in the near future will be able to easily carry cables. If you have not yet chosen installers, or if you are planning to do the installations by yourself, be sure to throw PVC pipe tunnels, whose entrance will be located under the foundation at the location specified on the project of connections, and make the outlet of that inside the building in a utility room, where the water meter and electrical box will be done. If you don't do it now, in the future you will be forced to forge through the concrete floor and dig over a meter deep hole to join the water. It will be a waste of time and unnecessary extra work. For the soil compaction, we use the tool that you can watch on the film now. This is one of the most widely used models of compactors. Its weight is 90 kilos and is designed for compaction of aggregate layer up to 30 cm thickness. So in our case, the whole job will split into 3 parts. Theoretically, the foundation should be filled with the same aggregate which is used in road construction. In practice, however, the cost of such material at such enormous quantities could ruin you. It is therefore necessary to consider the cheaper alternative. In the presented building site, aggregates used coming from another excavation. It is a mixture of gravel and sand fraction from 0 to 3 mm, remained in moisture content, which allowed us to robust compaction it. You can't underestimate this part of the work. Don't throw any garbage or remains of the blocks, bricks, etc., because it may result in the collapse of the floor, which can occur, for example, after a few months from the end of the construction works. In that case, your house will go to the renovation. But the worst will that you wouldn't know whether the renovation will bring the expected effect at all, and that story will not repeat after a few months. So watch carefully if the contractors are doing this job reliably, and if you're working by your own, treat this part as seriously as the other elements of the building structure. In particular that together with the laying of the concrete floor, all this job took us only 2 days, so there is no anything to save on it, at least in terms of the time. After thorough compaction of the first layer, the operator proceeds with the alignment of the next layer. The choice of the operator is also very important. It is good to find someone with the appropriate experience and practice. He should have a valid insurance against any damage that during such a works may happen quite often. As far as slightly damage that can be repaired by a bricklayer is not a problem, some structural damage so severe that exceeds the financial capacity of the operator will be able to be financed from his insurance. Sometimes operators have to work in close proximity to other buildings, and during a maneuver he can damage the neighbor's wall. I experienced once such a situation. Luckily that was only inconsiderable damage to the facade, so I fixed it without incurring virtually no financial costs. Nevertheless, it is worth to predict that kind of the situations and prevent them. The need to increase the height of the plot and such large quantities of aggregates is not happen to construction sites very often. Commonly, the soil excavated during foundation works is suitable for compaction and you will manage to use it to bury the foundations. But thanks to those conditions that arose in this specific case, I was able very thorough to show all works related to the foundation, soil compaction and the implementation of the concrete floor. In the film number 1, I mentioned that it is worldwide to perform geological soil testing before buying a plot and to figure out what is the zoning. Then you will be able to estimate the potential additional costs and decide whether you are going to deal with them. If you are planning to build a fireplace, you should also now make a lead to the air supply. If you plan to perform mechanical ventilation, you should consult the manner of its execution before laying on the concrete. It's not easy to hit with the appropriate height of the aggregate, and as you can see now, sometimes you will have to remove the excess so as to leave sufficient space for the concrete. Now you can see how the properly compacted base look like. Work is nearing completion. After the final thickening of the third layer, we are ready to perform the last action provided for in the first part of the tutorial. Concrete is already ordered and the works associated with it will start the next morning. Now you can see the equipment that's going to be used during the works. So here we have concrete mixer and a pump that will pour the concrete. We'll use concrete class B10, but you can also use structural concrete B15 or B20, there is nothing stands on the way. Before we will start, it is good to lay the building foil, which prevents mixing of concrete with aggregate. Additionally protects concrete against too rapid loss of water, which will help us to carry it. The foil will also provide some basic waterproofing. The main waterproofing will be done on the top of the slab. Around the edges of the walls we are fixing dilatation. As you can see, the easiest way is to develop it and immediately press by concrete. The floor that we are now doing is a primer under the proper ground floor. The slab which is now arise in the future will be isolated with the heat seal label membrane, the same which we use below the foundation walls. On the top of such a protected concrete, we will put electrical, water and central heating installation wires. After the installations are done, 15 cm thick layer of thermal insulation will be done, made by expanded polystyrene designed for flooring. Then an additional layer of polystyrene provided under floor heating if this is planned. At the end, we will make 7 cm layer of reinforced concrete, which will be the last layer, perfectly smooth and leveled, which will base for wooden panel, tiles, epoxy resin or any other finishes. Let's get back to discussing the footage. Please note that we pre-distribute concrete mix using ordinary garden rake. We need to heat with the amount of concrete to be surface of that was neither convex nor concave. It is a little bit confusing, especially that we don't use any leveler. Though seemingly arrangement of the concrete seems to be relatively easy to perform, however requires a lot of attention from the contractor and a bit of experience. After pre-arrangement, we proceed to smooth concrete, and to this end we use a styrofoam trowel. As you can see, one person is able to fulfill this job without any major problems. So we came to the end of the first part of the guide. We performed together widely considered to be the most problematic part of the construction. Colloquially, they said that is enough to get out from the ground and the rest will go smoothly. There is a grain of truth in this saying, provided that the work has been done correctly. While if the next steps will bring us any trouble or not, on this in second section, performing load-bearing walls.